All right. So page 359, chapter 5, lesson 2, sequences. Yep. Okay, just copy down and then catch back up. That's all right. It happens. Okay. What's that? Is it not the right page? Oh, I'm on 357. Sorry. So we'll start the lesson at the beginning of the lesson. I misspoke with the number. Okay. Vocabulary startup. A sequence is an ordered list of numbers. Stop talking. Each number is a sequence is called a term. In an arithmetic, like it's arithmetic, but arithmetic sequence, each term is found by adding the same number to the previous term. Same number. That is the key thing here. Same number. Where is highlighter? There we go. Same number. Complete the graphic organizer below. And yes, this is how simple this section is. Numbers continue each sequence. We have 1, 3, 5, 7. What do you think is next? 9.
Is that seriously hard?
That's literally about how challenging this is.
I actually might be able to do
1, 1.5, 2. What's next? 2.5. Then 3. Then 3.5. Describe each sequence. Add 2 to the previous term for this one. And then add 0.5 to the previous term. Ooh, previous term. And that's what we're going to be writing on our homework. It's going to be add that to the previous term, and then eventually we're going to be doing more in the series or sequence. The homework that you guys are going to be doing on McGraw-Hill tomorrow is going to be graded wrong. I have to manually grade it, but that's what I expect you guys to have. Add 0.5 to the previous sequence or previous term. Real world link. The number of students who went on each horseback riding trip is shown. Do the numbers present the terms of an arithmetic sequence? Explain. So the first trip there was 15. Second trip there was 16. Okay, that increased by 1. Third trip, it was increased by 2, by 18 to 18. Fourth trip increased by 3. Fifth trip increased by 4. That is not a sequence. No. The sequence has different numbers. Is it a pattern? Yes. Is it a sequence? No. A sequence has to have the same number. So you're writing that down since you didn't have your book? Everybody's writing it down. Describe and extend sequences. An arithmetic sequence, the terms can be whole numbers, fractions, or decimals. Okay? It doesn't have to be a whole number. It can be a fraction or a decimal. Describe the relationship between the terms of the arithmetic sequence 8, 13, 18, 23, and then write the terms of the sequence. That is the instructions for 15 of the 17 questions on the homework. So we have 8 plus 5 is 13, and another 5, another 5. So to continue the pattern in the next 3 terms, we have the next 3 terms are 28, 33, and 38. It's just increasing by 5.
So we're allowed to use a calculator, right?
Yeah, you're allowed to use a calculator here, but you won't need a calculator on the homework today. Well, let me rephrase that. It's very unlikely you'll need a calculator. Describe the relationship between the terms of an arithmetic sequence, 0.4, 0.6, 0.8, and 1.0. Then write the next 3 terms in the sequence. So we are increasing the term, or add 0.2 to the previous term, and the next 3 would be 1.2, 1.4, 1.6. That kind of did come off as sounding like singing.
It did.
Describe the relationship in terms of each arithmetic sequence. Then write the next three terms in the sequence. So, this is just like your homework. What's happening to the terms, Caden? Yep. So we have, this is how you'd write your homework answers. Add 13 to the previous term. So that is exactly how you're going to be doing your homework. And then we have to say what the next three terms are. So 39 plus 13 is 52. Then 65. And then 78. I spread them out when I copy paste from the book. But you guys have the room on the left in the margin to do that. I have it here so I don't have to keep moving around the screen if somebody's watching this on, their laptop, TV, phone, whatever it might be. That way they're not getting dizzy. Yeah, you cast your screen. That's how I watch YouTube all the time on my smart TV. I watch Twitch, YouTube. I throw SoundCloud up there. For this one, we have 4, 7, 10, 13. That is increasing by 3. Add 3 to previous term. $16, 19, 22. And if you are copying this down because you don't have your textbook right now, please make sure that you're writing what example we're doing and when. And do you have a pencil by chance? Please use pencil for doing math. Because math is about making mistakes and recovering from those mistakes. For this one, 1.0, 1.3, 1.6, and 1.9. It looks like we're adding what? Add 0.3, 0.3. Make sure you write 0.3. Because if you just do 0.3, it could look like you're saying add, period, and then 3. Add 0.3 to previous term. 1.9 plus 0.03. And finally, this one just adding 0.5 to previous terms. No, you guys are going to shoot through this so fast. 4.5, 5.0. Like I said, last period, and they were being chatty, half the class who wasn't chatty finished their homework already. Then they just have to go into McGraw-Hill. Speaking of McGraw-Hill, when you guys enter this onto McGraw-Hill, if you want to just copy and paste the add blah to previous term, that's one way to save yourself a little bit of time in the first 15 questions. Like if you were to, when you're entering on McGraw-Hill, yeah, if you type it in for number 1, if you highlighted this whole thing here, then you would just have to change this part here. Sure. I mean, here, let's owie. So let's do it. Since we have time, this will only take a moment. There's just too many clicking that we have to do.
It's kind of stupid first.
Yeah, it's not too efficient.
Are you guys really
So for example, number 1, And then if you did copy next, actually I wonder if that, so next, and then I just do this, and then I enter
What do you press there?
Control V, Control C. Control C for copy, Control V for paste. All right, back to the lesson at hand. Write an algebraic expression. Now here's the only part that might be a little confusing, but it's already stuff that we've done before. So in a sequence, each term has a specific position within the sequence. Consider the sequence 2, 4, 6, 8. First position is the 2, second is 4, third is 6, fourth is 8. Notice that the position number increases by 1. So the position number increases by 1, and the value of the term increases by 2. So to break it down right here, it shows plus 2, plus 2, plus 2. The position increases by 1. So it's just like multiplying the number of the position by 2. So for an algebraic expression where n represents the position in the sequence, the value of the term is 2n. No matter what position you're in the sequence, if you want to know what position 90 would be, so if position 90, it would just be 2n, so that's 180. That's what the 90th position would be. Nope. Yeah, as I told last period, it might have been this period, I don't know, time traveling. I doubt you're going to need calculators for this. The greeting cards that Meredith makes were sold in boxes at a gift store. The first week, the store sold 5 boxes. Each week, the store sold 5 more boxes. The pattern continues. What algebraic expression can be used to find the total number of boxes sold at the end of the 100th week? What's the total? So we have 5 boxes for each position. So it's just 5n. So we would multiply 5 times 100 on the 100th week. She sold 500 boxes that have been sold. So she's doing pretty well. All right, now here's the one that will... This is the only part that confused anyone last period, so hopefully we're able to make sense of it here. If the pattern below continues, what algebraic expression can be used to find the number of circles used in any figure? How many circles will be on the 50th figure? So we have figure 1, there's 3 boxes, or 3 circles. Figure 2 has 3 and 3, which is 6. Figure 3 has 9. So what's it increasing by? 3 for each position, right? So we have 3n is going to be our algebraic expression. And then after the 50th, it's going to be 150 circles. Oh, and also, on the test, I didn't mark you off if you didn't put words into your word problem answers. But if there's words in the question, have words in the answer. Okay? I can't emphasize that enough. It surprised me how many students did not write, as far as like the pieces of pie question, how many of you did not answer that? You just write 30. Well, 30 what? It's asking you how many pieces. You're just saying a number. I need a full response. Yeah, 30 pieces or 30 pieces of pie. Yeah. Yep. Yes. I also had people saying that there were like 360 pieces of pie.
What?
It's amazing just the lack of logic for so many of the questions that people answered. With multiplication and division, though, it is a little bit easier to get tripped up, but the addition and subtraction ones, yeesh. Oh, and also if you didn't simplify your answers, you got only half the point. If you didn't have a negative where it should be negative or positive when it should have been positive, you got half the credit. I want you to do 1 through 5 right now. I'm going to start doing number 1 in about 20 seconds or so, and we'll go from there.
So are all the ones on our homework tonight 3, like 9, 18, 27,
This is just like the first 15 questions.
Oh, yeah.
Yes, sir?
Can we just put, like, for the first one, it's obviously add 9. Can we just put add 9? And we have to
I want you to write the way that we had the other examples. That's why they're examples. You write it that way.
Okay.
That's why there's 2 lines there. Oh. Yeah.
Are they harder or easier?
All right, you should be done with those 3 by now. For the first one, we just added 9 to the previous term, and it became 36, 45, 54. For number 2, we added 5 to the previous term, which became 24, 29, and 34. For number 3, we added 0.1, so it became, or to the previous term, 1.4, 1.5, 1.6. So this one here, we have Hannah has a doll collection. The table shows the total number of dolls in her collection for 3 years. Suppose this pattern continues. Yep. Write an algebraic expression to find the number of dolls in her collection after n years. How many dolls will Hannah have after 25 years? So what's happening for this? We're adding 6. We're adding 6. And remember that multiplication is repeated addition. So we have the algebraic expression is 6n, where n represents the number of years. And after 25 years, we have 6 times 25, and we can do that in our head. So 150 dolls. 150 dolls. And if you have 150 dolls, I don't care what kind they are, that's scary. Not all dolls are creepy, but if there's 150 of them.
Oh, did you see the house in him? That in the window, their house, you know, is creepy.
Is it?
Just from the outside. And then in the window, there's a Chucky doll.
Nice.
This girl in the world record books, she has over 2,000 Barbie dolls.
Yeah, I guess that's a little different. That could be a collection that is logical of Barbie dolls. All right.
Yeah, that could also.
Last question. Building the essential question. Explain why the following sequence is considered an arithmetic sequence. Yeah. After we are done with this and I pass out when I'm passing out the homework, yes. Thank you for asking and not just interrupting. I appreciate it. Thank you. Or just going off on a tangent. That doesn't happen enough. Thank you. Not by you. I'm just saying students in general. 5, 9, 13, 17, 21. It is a sequence. Yes, it's a sequence because all increases by 4. Yep. It all increases by 4. And speaking of by 4, I say bye to you. Bye.